dear friends, welcome to GATE Academy Global. Before starting today's session, I would like to take the feedback or the concurrence from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. My dear friends, the agenda behind today's video must be very precise and clear. We have been reached to the third lecture over the engineering mathematics where we are preparing ourselves for the GATE 2022, taking the references or taking the help of the questions which has appeared in GATE year of 2021. I have taken all of the questions which have appeared in the different branch, which it starts from the civil engineering, chemical, electrical, electronics, instrumentation, mechanical and PI. And even I would urge from each one of you, try to share this session to maximum of your juniors, seniors or the colleague, because this session is literally gonna be benefited to all of us, because with the help of such a concise form of the 1 hour which we spend together in between 9 to 10, definitely you are going to learn so many important concepts. And yes, the each and individual questions has been bifurcated or consolidated in a form of topic. That means topic by topic we are going to cover the complete engineering mathematics, taking the reference of the question which have come in the GATE 2021. GATE 2021. Agreed? Anyways, if the quality of video as well as audio both are perfect, you can write perfect over the live chat. Then we are ready to go. My dear friends, so let me take the questions which we are going to take in today's session. Just a minute. So total 7 number of questions we are going to take in today's session, and most of them have been falling from the chemical engineering. So the questions which I am going to discuss in today's video, definitely most of them are coming from the chemical engineering, and even few of the questions have come from the civil engineering. And the topic which we have been covering since last 2 days were linear algebra. Even in today's video also we are going to cover the same topic, and that's nothing but the linear algebra. But yes, this would be the last video over the linear algebra, and from tomorrow onwards we would take the questions which have come from the domain of limits, continuity and differentiability. Yes. So without getting delayed, let me focus over the first question. Yes. Let me bring this problem into the working board. See what the problem states and what would be the best most answer for this given problem. It is a well designed problem. Definitely I won't rate this problem as a tougher problem, but yes, it is a type of a logical problem. So once you apply your aptitude, then only you would be able to get this answer fast as well as error free. Let me see what the problem exactly states. My dear friends, the problem says let A be a square matrix of a size of n cross n where the n is greater than 1. That means it has been a square matrix with the order at least 2 cross 2. The elements of A, which has been indicated as Aij, are given by Aij is being I into j for I greater than or equals to of j, and simply 0 if the I is less than j. Then the determinant of the matrix A is. The 4 different options were attached along with this problem. Option A is n factorial, option B is 1, option C is n factorial to the power of 2. Do not get confused with the n square factorial. N square factorial and n factorial to the power of 2 are the 2 different entities, and last is 0. So just wanted to know from each one of you what would be the best most answer for this given problem. My dear friends, it has been clearly indicated it's a type of square matrix. Yes. So the given data, if I would try to consolidate given data, the order of matrix has been clearly written as n cross n. That means it's a type of square matrix. A has been a matrix of n cross n. It's a type of square matrix. That's the first thing. A square matrix. And now one more data has been given along with this problem, that is n is greater than 1. That means the order of the matrix is minimum 2 cross 2. The minimum order of this matrix is 2 cross 2. Now even the data which has to be filled with the matrix A has been written as a Aij. May I know what is the Aij? A is the element which has to be fed over the ith row and jth column. Yes, and obviously a matrix is made of columns as well as row only. So this has been clearly given as a Aij. And now even they have given a specific procedure how the data has to be fed within the square matrix of A. My dear friends, what I would be doing for the better understanding, I would take the square matrix which has the order of n cross n, Yes. In case of n cross n, how many number of rows and columns would be there? Obviously n number of rows and n number of columns you will be having. So the first data goes like A11, then here goes A12, A13, A14, and it goes till A1n. Similarly, here it would start from AN1, it would go to the AN2, and at last it would feed up to the ANN. But the data has been precisely following a certain pattern. May I know what it is? If I is greater than equals to of j, what does it mean of it? When the place of row is greater than equals to of place of column, may I know which are the places would satisfy this requirement? Obviously, A11 satisfies this requirement. Not only that, even A22 satisfies this requirement. Even A33 satisfies this requirement. ANN satisfies this requirement. Yes, probably this must be clear to all of us. Not only that, even if you go down to the next row, the next element which comes into the picture is that's nothing but the A21. A21 also satisfies this requirement where the location of row is greater than the location of column. You can see very well the location of row is being placed in the second row and the location of column is at 1. Location of column is at 1. Similarly, here goes A31, A32, everything is being satisfied. Everything is being satisfied. Obviously, all of the data which are coming below this row would be satisfying this requirement. And now if you take the data which has been left out, like if I'll take the reference of, in the first row itself, second column, you yourself would be able to see the value of I is 1, the value of j is 2. Definitely it is not going to satisfy this requirement, and here you yourself would be able to understand the j is greater than I, and hence this data has to be fed as 0. This data has to be fed as 0. So you can take the reference of any of them. So here you can take A13, here you can take A23, everywhere. Even you can take A1n, you can take A2n. My dear friends, if you will start feeding the data now, all of the data or all of the positions which have been marked with the yellow color, no, they are satisfying this requirement. And similarly, all of the data or the elements which has been marked with a pink color, no, they had to satisfy this requirement. Put together, it is gonna be a type of lower diagonal matrix or lower triangular matrix. So let me start feeding the data. Yes. So by satisfying this requirement, I would start feeding the data. So how the structure it would be? See, A11, the value of I is 1, value of j is 1. If I'll multiply them together, the worth which we get, it's simply going to be 1. The remaining data towards right hand side, it's simply going to be 0, 0, 0. Similarly, if I take the reference of A21, what would be the worth of the element which will be fed over here? It's simply going to be I into j. The value of I is 2 and value of j is 2. So simply it's going to be 2 into 1, which would be 2. Similarly, if I take the reference of A22, it becomes simply 2 to the power of 2. I think it's better to write 2 to the power of 2, although the value becomes 4. Remaining, all of the components would be 0. That must be known to me. If I take the reference of this element, what it is? 3 into 1, which would be simply 3. Similarly, 3 into 2, that would be simply 6. And here it would be 3 to the power of 2. And that goes on. And here, the principal diagonal elements, what you will be having, the worth would be always like 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, 4 to the power of 2, just a minute. And in the location of n cross n, or at the row n as a column n, the worth would be n to the power of 2, Yes. Till this point, each and everything must be clear to all of us. Anyways, I am not focusing over the rest of the element which would come over here. Why I am not focusing over those components? My dear friends, as you must be knowing, the determinant of upper triangular matrix or the lower triangular matrix is very same as the multiplication between their principal diagonal elements. What it was? It was a matrix A. If you will take its determinant, you need not to calculate the determinant into the manual method. You can just multiply their all possible principal diagonal elements. So the multiplication would be 1 square into 2 square into 3 square. How many number of rows or the columns you will be having? As it is b in order of n cross n, obviously n number of rows and n number of columns you will be having, and they would get multiplied together. Yes, and once you multiply them together, what you can do? You can write 1 into 2 into 3 dash dash dash, it goes to n to the power of 2. This to the power of 2 has been raised to complete power, and 1 into 2 into 3 getting multiplied till n can be written as n factorial, and to the power of 2 could have been written as n factorial to the power of 2. Yes. It was a well-designed problem, and I understand many of the students could have solved this with a manual method also. Otherwise, the best method to get this answer would have been n factorial to the power of 2. See, even you could have smashed this problem with a different methodology. What could have been that methodology? You could have assumed the matrix which you have been choosing is an order of 2 cross 2. Yes, that could have been the another method. Let me take the another method. What I am going to do, rather taking arbitrary value of n, I am fixing the value of n itself. And again, the data which will be fed over here, I would be following the same process which has to be followed over there. What are they? You can see yourself. Again, off diagonal element above the principal diagonal element would be fed 0, and lower side you had to follow this process. So here the value which we'll be having, it's gonna be 1 into 1 because it has been placed on the first row, first column. Here it becomes 2 into 2, that becomes 2 to the power of 2, and here it becomes what it becomes. It has been in the second row and first column, so it's gonna be 2 into 1, and here obviously the value has to be 0. Now, taking the reference of 2 cross 2 matrix, you could have figured it out of 4 number of options which would be the bestmost answer. Anyways, take its determinant. The determinant what we got, it's simply gonna be 4 minus of 0, which is nothing but 4. So may I know, out of the 4 number of options, which are the options are getting satisfied? May I know the example which we have taken earlier? What was the value of n? The n was 2, and if I take 2 factorial, obviously option A is not getting satisfied because the answer which we got as a determinant was 4. Even the B is also not getting satisfied, D is not getting satisfied. Here also we are getting the same answer, which is nothing but C. I just wanted to ask from each one of you whether you know this process or not. For upper triangular matrix or lower triangular matrix, its determinant is very same as the multiplication between its principal diagonal element. If you do not understand, at least you must be knowing, if you have an upper triangular matrix or the lower triangular matrix, in that case their eigenvalue multiplications, how many eigenvalues you will be having? N number of eigenvalues. It's very same as the multiplication between their principal diagonal element, which is 1 square, 2 square, 3 square, goes to the n to the power of 2. And you know one of the important property which is followed by the eigenvalue multiplication. The multiplication between the eigenvalues is very same as its determinant, which would be equals to of mod of A. Yes, I have used the same methodology over here. So tell me, what would be the bestmost answer? The bestmost answers would be C. It was not a difficult problem, but yes, it was a sort of problem where many of the students could have stuck themselves. Yes. Anyways, now it's right time to move into the next question. My dear friends, here goes the next question. Yes, it was a type of NAT problem. You have to read this problem carefully, and then you have to get the appropriate answer over here. So let me do one thing. Let me bring this problem into the working code. Here goes the question number 2. Yes. Here goes the question number 2. This problem have appeared in chemical engineering year of 2021. See what the problem states. A, B, C and D are the vector of length 4. My dear friends, nobody should have any doubt how the vector has been written in the form of matrix and how the matrix can be written in the form of vector. Yes, that we have dealt earlier, that we have dealt in the last class. Whenever you have been dealing with a vector, by default that matrix has to be a column matrix or the row matrix. Here it has been clearly known, it has been a row matrix. That is for sure. How many number of vectors or how many number of row matrix we have? The 4 number of vector or the 4 number of row matrix we have. The first goes vector A, the second goes vector B, third goes vector C, and the last goes vector D. Or I can say the first one is a first row matrix A, second row matrix B, third row matrix C, fourth row matrix D. And their elements are clearly given as a A1, A2, A3, A4, similarly B, similarly C, similarly D. Okay. Now here goes the next sentence of this problem. It is known that B is not a scalar multiple of A. Also C is linearly independent of A and B. Further, D is being 3A plus of 2B plus of C, the rank of the matrix. And now, may I know how the matrix has been framed? The matrix has been framed using the component of vector A, B, C and D. You had to get its rank, where the additional information regarding the vector A, B, C and D has been provided with this problem. Nishant Yadav, yes my dear friends, it's meant for all of the branch. What I am saying, probably you may not be knowing what was the basic agenda behind taking this series. What I am doing, all of the problems which have come in GATE 2021, either of the branch, from chemical, civil, mechanical, computer science, electrical, electronics, instrumentation, I have consolidated them together in a form of separate topic, and I am teaching the concept with the help of those questions, obviously in terms of different topics. So definitely it's going to help you if you are going to prepare or if you are going to appear in GATE 2022. Absolutely my dear friends. So tell me, what would be the best most answer? Whenever I am teaching, I would expect it must be two-way communication. So whenever I ask what would be the best most answer, at least you can guess that answer over the live chat. So at least I'll have that understanding that yes, you guys are well acquainted, or you guys are connecting myself. Tell me what would be the best most answer for this problem. What would be the best most answer for this problem? Anyways, let me focus over this problem. At very beginning, I would write what are the important datas are given along with this problem. This used to be the pattern of our booklet also. In GATE Academy, first we write given. So in the same way, we are going to smash this problem out. My dear friends, what are the different datas are being given? You can see very well A, B, C and D, although they have been written as a vector, obviously with the length of 4, that means that each of the vector have got the 4 different component in the 4 different directions, A1, A2, A3, A4. Anyways, this length 4 does not make much sense. The given data, we have got the 4 row matrix. 4 row matrix has been clearly given along with this problem, which starts from A and ends at D. A, B, C and D. That's the first important thing which has been supplied along with this problem. Why I am taking the reference of this data? Because the amalgamation of this 4 row matrix or the 4 vectors are going to make another vector. It's going to make another vector. Reena Kumari, the answer have started coming. Anyways, the second information which has been given along with this problem, once you read this, it is known that the B is not a scalar multiple of A. That means B cannot be extracted by a certain scalar multiplication with A. No, it is not possible. What does that mean of it? That means the B and A are linearly independent. I am just writing it Li. That's the first information. B is not the scalar multiple of A. Next, C is linearly independent of A and B. If I would like to write this data in a form of mathematical equation, C is linearly independent. What does that mean of it? That means C cannot be retrieved by constant multiplication with A as well as B and their linear addition. And at their linear addition, obviously that is also not possible. A and B, they were linearly independent, but now I have got another information, even the C is linearly independent from A and B. C is linearly independent from A and B. Then next goes the last information. What it is? It has been clearly written. The D has been the linear dependency over matrix A, matrix B and matrix C. What this equation indicates? The D have got the linear dependency. The D is linearly dependent on A, B and C all. A, B and C all. Agreed? Till this moment of point, each and everything must be clear to all of us. So as far as the new matrix which have been formed, taking the reference of 3 vectors, obviously we ourselves would be able to understand this last row are the linearly dependent on starting 3 rows. Similarly, the starting 2 rows are linearly independent to each other. Even the third row is linearly independent from the first as well as second row. What is the outcome we can get out of this? That is very sure. the number of linearly independent rows or column. Here we have been discussing about the row, so I'll stick to myself to the row only. The number of linearly independent rows are very same as the rank of the given matrix. And how many number of linearly independent rows we had? This row, and this row are the linearly independent rows. How many? They are in count 3. So the rank of the matrix is simply 3. So far this sort of problem has not been framed in GATE examination, where the core theory of the rank has been framed as a simple problem. Yes, the answer have started coming. Rinki Kumari is saying 3. Kalyani Vaidya is saying 3. Nishant Yadav is saying 3. Afat Sheikh is saying 3. Obviously the best most answer is gonna be 3. Yes, this is the best most answer for this given problem. Agreed? So till this moment of point, probably each and everything must be clear to all of us. Now it's right time to move into the next question, which is gonna be the question number 3. Which is gonna be the question number 3. Here goes the next question. My dear friends, usually all of the questions which I am picking, they are from GATE 2021, but deliberately I have picked one problem from the EAC which has appeared in electrical engineering, because this sort of problem are expected even in GATE exam also. So I have taken the reference of this problem also. Yes. Tell me what this problem exactly indicates. So let me focus over this problem. It has been clearly mentioned, the problem have come in engineering services examination in the technical portion of electrical in year of 2019. Here the matrix A has been clearly given, which is a type of square matrix in order of 2 cross 2. Obviously the element has been, just a minute, element has been this. Yes, then A into A star will be, where the A star is the conjugate transpose of A. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? My dear friends, if we will talk about the order of this matrix, the order of the matrix has been the 2 number of rows it contains, the 3 number of column it contains. And once you will multiply A into A transpose conjugate. What does it mean by the transpose conjugate? The name itself is self-explanatory. First you have to take its transpose, then you can take its conjugate, or you can take its conjugate first and then you can take its transpose, and you have to multiply them together. Anyways, let me do so. So the element what we have is gonna be 2i, here it's gonna be 3, here is gonna be minus 1 plus of 3i minus 5, and here it's gonna be 4 minus of 2i. Obviously it is in order of 2 cross 3. Once you'll apply its transpose conjugate, so either you can take transpose first, and after that going into the each and individual element you can take its conjugate. So I am following the same process. First, the order of the matrix was 2 cross 3. If I'll take its transpose, definitely it would convert into the 3 cross 2. So how many number of rows and how many number of columns you will be having? 3 number of rows you will be having, 2 number of columns you will be having. 3 number of rows and 2 number of columns you will be having. Agreed, no? Anyways, the first row would become first column, second row would become second column. Okay, let me do so. So here it becomes 2 plus of 5, here it goes 3, here it goes minus 1 plus of 3i, yes. And similarly here it's minus 5, here it's I, here it is minus of 4 minus of 2i or 2j. Next thing, so far we have only calculated its transpose, but now it's time to take its conjugate. If I take its conjugate, what are the differences you would be experiencing? This plus sign would become minus sign, this plus sign would become minus sign, this plus sign would become minus sign, and similarly this minus sign would become plus sign. So probably it must be known to all of us, if you have got a complex variable a plus of jb, if you take its conjugate, the result used to be a minus plus jb. If the value is plus over here, it becomes minus, and if the value is minus, it becomes plus. Yes. Till this point, each and everything must be clear to all of us. Anyways, what does that mean by the conjugate over the 2D plane? Over the 2D plane, let's take, you had a point 2 plus of 2j. If you will take its complex conjugate, the real part would not change, whereas the sign of the imaginary part would change. It becomes 2 minus of 2j. This point comes somewhere here. Similarly, if you have minus 3 plus of 3j, and if you take its complex conjugate, the result would be minus 3 minus 3j. So whenever you take the complex conjugate now, basically you take the mirror image of that point taking the reference of x-axis. Taking the reference of x-axis. I have seen many of the times the student used to have doubt, sir, why the conjugate is being performed. My dear friends, the conjugate is being performed just to take the mirror image of that point taking the reference of x-axis. Even if you will take the complex conjugate of minus 3 minus of 3j, which would become minus 3 plus of 3j. So again, it has been placed to its same place. And now the next thing comes in a mind, sir, where these tools are being used. These tools are repeatedly used in Paint tool, what we use in Microsoft. Even it is repeatedly used in case of Photoshop, where we had to take the reversal of that image or reversal of that point taking the reference of x-axis. Yes, no? See, although it has been a point, you can have a structure over here. And the structure would be made of point only, no? Point only. And if you wanted to draw its mirror image taking the reference of x-axis, what would happen? Now you would be taking complex conjugate of each individual point. By default, each and individual point will get mapped over this plane, and now it is nothing but what? Mirror image of that structure taking the reference of x-axis. So at least one thing must be there within your mind. Whenever you are calculating the conjugate, basically you are performing the mirror image of that point taking the reference of x-axis. Agreed? Tell me what's the result we are getting, my dear friends. So how the multiplication would take place, as the first thing, and what would be the order of the resultant matrix. My dear friends, it has been a 2 cross 3 matrix, and if it is getting multiplied with the 3 cross 2, first we will see whether their multiplication is possible or not. Yes, the multiplication is possible because the number of column in the first matrix is matching with the number of rows in the second matrix. Yes, their multiplication is possible. That's the first thing. And now comes the order of the product matrix. Obviously, the order would be the number of rows from the first matrix and number of columns from the second matrix. And how the multiplication would take place? 2 plus I has to get multiplied with the 2 minus I, 3 has to get multiplied with 3, and similarly minus 1 plus of 3i has to get multiplied with the minus 1 minus of 3i. Anyways, try to get the answer, how much answer we are getting. Tell me, and get the answer, how much we are exactly getting. So, see. 2 plus I and 2 minus I, it's a simple identity. What it is? A square minus of B square. What is the A square? The A square is nothing but the 2 to the power of 2, that is nothing but 4. Minus of I square is nothing but minus of 1. So 4 minus of minus 1, that becomes 5 over here. Yes. Similarly, here the 3 gets multiplied with the 3, so obviously it would become 9 over here. Anyways, they all would be added together. And here goes minus 1 plus of 3i minus 1 minus of 3i. Again, the same identity has to be used. Here it would become a square is nothing but the minus 1 to the power of 2, that's nothing but plus 1. And here it becomes plus of 9. And that is nothing but 10. Agreed what I am saying? So only one answer have been so far, and the answer was B. Anyways, we'll check that. Similarly, the same multiplication has to be carried out. This was been the problem in EAC. Yes, it is a bit lengthier problem, but the result what you are getting now, it is gonna be Hermitian matrix. May I know what's the structure of the Hermitian matrix? The structure of the Hermitian matrix states A transpose conjugate is very same as A itself. Yes, is very same as A itself. Agreed? And in case of Hermitian matrix, by default one thing must be there within your mind. The principal diagonal element must be free from any iota component, or it must be completely real. And the elements which are supposed to come here as well as here, they must be in a form of complex conjugate. Anyways, once you will calculate this result, no, definitely the principal diagonal element would be pure real. You can see by yourself the first row, first column has been pure real. Even when you will calculate the second row, second column, that would also be real, because this is going to be multiplied with this. It would also be real, and the component which you will be calculating over here now, if I get the number over here as a plus of jb, by default the number here it would be a minus of jb. So obviously it satisfies the requirement of a transpose conjugate is same as a. So the best most answer what we are getting for this problem is going to be option C. It is taking unnecessarily long amount of time. That is why I am leaving up to you guys, and probably you would be able to smash this problem out. Now it's right time to move ahead into the next question. See, here goes the next question. Again, this problem have come in civil engineering in recent year. What the problem states, the two matrix has been given along with this problem. The first is going to be matrix P, which is an order of 2 cross 2. The second is matrix Q, which is an order of 2 cross 2. And now we had to find the value of Q transpose into of P transpose. And yes, it has been a type of MCQ. So obviously out of 4 options, you had to select the most appropriate answer. So what I would be doing, I would just be bringing this problem into the working board. Let me take this problem. So here goes the problem. So I would expect from each one of you, how many number of students are live? The 5 students are live. Probably at least 4 to 5 number of answers I would be getting over the live chat. Tell me what's going to be the best most answer for this given problem. What's the best most answer for this given problem? The calculation would not take much amount of time. You had to just take the transpose of the matrix Q, you had to take the transpose of the matrix P, and then you can multiply them together. Anyways, we could have used the 2 different methodologies. What are they? I could have used the first methodology. I had to calculate the Q transpose into P transpose. It could have been simply calculated by multiplying P and Q in this sequence and after taking the transpose. And we know from the identity, P into Q transpose or A into B transpose is very same as B transpose into A transpose. That means this transpose comes with each and individual matrix, but their sequence gets changed. Yes. So you could have done in this way. So what would be my first process? I would just be multiplying them together, and thereafter we will take its transpose. And I would suggest to all of you, if you guys are appearing in GATE 2022, you must be well comfortable for the calculation of their multiplication without doing much of the calculation over your copy. See what is happening. It is being 2 cross 2. Their multiplication would result a matrix with the order of 2 cross 2. See, this first row would get multiplied with this first column, and it would make the element of the 1 1, which would be kept over the first row and the first column. Anyways, let me start multiplying them together. The 1 would get multiplied with the 0, would result 0. 2 would get multiplied with 1, would result 2. Once we will add them together, 0 and 2 would result simply 2. Yes, agreed my dear friends. So obviously option A and option B has been ruled out. Why? Because in future, if you will be taking its transpose, no, the locations of the principal diagonal elements would not change. So rather calculating the element A12 or A21, why don't we straight away jump it to the A22? Let me calculate that also. So obviously there would be the multiplication between the second row of the first matrix and the second column of the second matrix. So let me multiply them together. 3 1 ja 3 plus 4 into 0, that is a 4. So simply the result what we get, it's gonna be 3. Anyways, at least in this problem, deliberately they have fed 2 as well as 3 as the principal diagonal element. That means I could not figure it out which would be the perfect answer. So definitely one more option has to be, or one more element has to be calculated. Let me focus over this element. This element has been placed over the second row and first column. So obviously for finding that element, you had to choose the second row of the first matrix and the first column of the second matrix. Let me multiply and add them together. So 3 gets multiplied with 0, that would be 0. 4 gets multiplied with 1, simply it would be 4. Yes, and once you will take its transpose, this 4 would be shifted towards this side. So the best most answer which we are getting for this problem is going to be option C. Yes. Yes, the answer have started coming. The Reena Kumari is saying the answer is C. Manish Kumar is saying the answer is C. Even if you want to calculate the worth of this location, may I know in which particular location this value has been filled it? It has been in the first row and second column. So obviously you have to take the reference of the first row of the first matrix and you have to take the reference of the second column of the second matrix. So 1 gets multiplied with 1, 2 gets multiplied with 0. In their addition would be simply 1. So end of the day, why don't we take its transpose? Principal diagonal element would not change its location. 4 would be placed in place of 1 and 1 would be in place of 1. So the best most answer is going to be C. The best most answer is going to be C. It was an easy problem. It was an easy problem. The second method would have been straight away calculate the transpose of the matrix Q, straight away calculate the transpose of the matrix P, and then in the same order you can multiply them together. You should not change their order, because once you change their order, probably the matrix multiplication may be true, but their answer may be different. So always I would suggest one thing: whenever there is a matrix multiplication, do not alter their sequence, because many of the times even the matrix multiplication itself would not be possible, and many of the times if the matrix multiplication seems to be possible, their answer would be different. So nobody should calculate like P transpose into Q transpose. You should follow the same process, and there also you will be getting the same answer. Anyways, let me move forward. Here goes the next question. This question have come in civil engineering. It has been a problem of a matrix having order of 4 cross 4, and the rank has to be calculated for this problem. It has been an MCQ. The 4 options were attached along with this problem. Obviously the one answer would be the appropriate most answer. Tell me what would be the best most answer for this given problem. For the better understanding, let me bring this problem into the working board. Here goes the problem. Tell me what would be the best most answer. I know many of us would do mistake over this problem. See, as I have been telling, whenever you have a matrix with order of 4 cross 4 or maybe greater than 4 cross 4, and if you had to calculate the rank of that matrix, always start cracking this problem in terms of linear dependencies between their rows or column. Because straight away, if you will start solving this problem for the calculation of rank manually, this problem would take hell amount of time, which would not be the great approach, at least for the gate. Yes, would not be the great approach for at least the gate. So what I would be doing over here, my dear friends, can you make a certain relationship between the rows and columns where they are linearly dependent? If any of the row or any of the column becomes linearly dependent, definitely its rank cannot be 4. Would you able to see somewhere? Yes, you are. See. If 3 got subtracted with the 1, the result is gonna be 2. 4 got subtracted with the 2, the result is 2. 2 got subtracted with the 2, the result is 0. 5 got subtracted with the 3, the result is 0. Agreed? Similarly, the same case goes like here, the 7 gets subtracted with the 5, the result is 2. 8 gets subtracted with the 6, result is 2. 2 gets subtracted with the 2, result is 0. 9 gets subtracted with the 7, the result is 2. So if you take the elementary operation like R2 tends to R2 minus of R1, similarly R4 tends to R4 minus of R3, definitely the 2 of the rows which have come in byproduct, they are matching to each other. That means out of 4 number of rows, at least 1 row has been figured it out that it's a type of dependent row. But you cannot ensure the number of linearly independent rows are 3. Even few more number of rows could be linearly dependent. So what I would say, whenever you have a problem related to the matrix where the order of the matrix is more than 3 cross 3, and if you had to calculate its rank, always I would suggest try to use your aptitudinal knowledge and try to make the relationship between their rows and column and try to make a certain linear relationship between their rows and columns. If it has been made by default, you can say the rank can't be 4. Agreed what I'm saying? This problem was not meant for calculation of calculation of rank manually. Nobody should start taking the determinant of 4 cross 4. The determinant is non-zero. In that case, the rank would be 4. If it is 0, the rank would not be 4. In that case, even the calculation of the determinant of a 4 cross 4 matrix would take a hell amount of time. Agreed to what I am saying? So at least one thing is quite sure, the rank of this matrix cannot be 4, because we got to know at least one row has been the dependent row with the rest of 3 rows, but still we are not sure whether few more rows are linearly dependent. So what I would do, let me take few number of elementary operations. See what are the elementary operations I have been feeding over here. Let's take R2 has been taken as R2 minus of thrice of R1, just to make this element 0. In the same sequence, I would be applying the elementary operation over the row 3, where the R3 has been taken as R3 minus of 3 times of R1. Similarly, here goes R4. Here goes R4 minus of 7 times of R1. Yes. So if I apply all of the elementary operation together, you would be having the new structure of the matrix with the order of 4 cross 4. May I know what are they? Anyways, there is no change in first row, remains same. The 3 gets subtracted with the 3 times of 1, obviously it becomes 0. Here it becomes 4 minus of 6, that is a minus 2. Here it becomes 2 into minus 6, that becomes minus 4. Any mistake is taking place, you can just recall over the live chat. And similarly here 5 gets subtracted with minus 9, it becomes minus 4. So at least the R2 got freezed. Yes. Similarly, if I take the reference of third row, the same process has to be followed, but yes, the elementary operation which has to be performed have got changed a bit. My dear friends, instead of 3, the value has to be 5. So here the 5 has to get subtracted with the 5 times of 1, that's simply 0. See here, the 6 has to get subtracted with the 5 times of 2, that's nothing but 10. 6 minus of 10, the result would be minus of 4. Similarly, here goes 2 minus of 10, here it becomes minus of 8. And similarly, here it becomes 7 minus of 12. Yes, 7 minus of how much it is? 15, sorry. The result what we get, it's going to be minus of 8. Yes, similarly, the same process has to be followed for the row 4. So here the 7 has to get subtracted with the 7 time of the first row. The result is simply going to be 0. Here, the 8 is going to be subtracted with the 7 times of 2, that's nothing but the 4. The result is simply going to be minus of 6. Yes, 8 minus of 14 minus 6. Yes, similarly, 2 gets subtracted with, here it becomes minus of 12. And similarly, 9 gets subtracted with minus of 21, so here it becomes minus of 12. Yes, till this moment of point, each and everything must be clear to all of us. Now what we can do, just to simplify this problem, see, minus 2 could have been taken out common from here, minus 4 could have been taken common out of this, and similarly minus 6 could have been taken common out of this. Anyways, the common factor which will come out definitely does not make any sense over the calculation of the rank. So the element which has been left after is simply going to be 0, 1, 2, 2, 0, 1, 2, 2, 0, 1, 2, 2. Yes, 0, 1, 2, 2. Now again, if I apply the elementary operation like R3 tends to R3 minus of R2. Similarly, R4 tends to R4 minus of R3. Now here also one mistake the people would do. What they would do, they will subtract R2 from R3 and they will make 0. They'll subtract R3 from R4, they will make 0, and even they will make this also 0. No, my dear friends, out of 3 number of rows, you can make only 2 rows 0, because once you will be taking the reference of another row, and if that row itself became 0, you cannot take the reference of that row once again. So you can apply only this many elementary operations. Okay. So what is the conclusion we are getting out of this? So the first row remained as it is, 1, 2, 2, 3. These are the elements we had. Now, anyways, the row 2 would remain as it is, and now it would become 0, 0, 0. It would become 0, 0, 0. Now you yourself would be able to understand the two rows were the dependent rows. That is why after taking the elementary row operation, they vanished. They vanished. So tell me, what would be the best most answer? It is option C. And I know whenever this sort of problem would come into the GATE examination, many of the students would think, sir, after doing much of the effort, I did not get the second row, which was dependent on the rest of the row. So I fed the answer is 3. No, the 3 is the wrong answer. The best most answer is C. The best most answer is C. Till this moment of point, each and everything must be clear to all of us. Must be clear to all of us. Now, if you use the another method, what we do? If the rank is not found 4, so what I would do? I would select the minor of 3 cross 3 and we'll take its determinant. My dear friends, if you'll use that methodology now, how many number of minors you can select? You can use this minor, 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 you can use this minor. And once you'll start taking the determinant now, after 2 or 3 number of determinant, you yourself would get frustrated because all of them are going to result the determinant as 0. So that is what I am saying. If you'll follow that process where you are checking the rank as 3 by its determinant of the minor 3 cross 3, you will get frustrated. You will get frustrated. I know many of us would write the answer as 3, whereas the best most answer is 2. You yourself would be able to analyze this. You yourself would be able to analyze this. Till this moment of point, probably each and everything must be clear to all of us. Now, it's right time to move forward and take the next question. Yes. This sort of problem have come earlier in computer science. Almost the same pattern of the questions has been repeated, and this problem have come in mechanical engineering, obviously recent year. So without getting delayed, let me take the screenshot of this problem and bring it to the working board. Here goes my working board. Here goes your working board. See what the problem it states exactly. See, let the superscripts T represents the transpose operation. Consider the function f of x. My dear friends, we had a function, but the function has been written in a form of the matrix linear form where the x has been a matrix, we had to take its transpose, q has been a matrix, and similarly x has again be a matrix, and now it has been multiplied with the r to the power of t as well as x, Agreed what I am saying? So put together with the help of matrix multiplication, they have been forming a certain function. So by default, the matrix which comes out after this multiplication has to be in order of 1 cross 1. Then only it would strictly be forming a function f of x. Yes. And once you'll see the dimensions of x, q and r, you yourself would be able to judge, yes, they are making the order of the matrix or the product of the matrix which is coming out after the calculation is nothing but the 1 cross 1. See how x and r has been in the order of n cross 1. So if we'll talk about the given data, first focus over the order of the individual matrix. The x and r both have been in the order of n cross 1. Q is a symmetric matrix of the order of n cross n. Q has been a symmetric matrix with the order of n cross n. So now you yourself would be able to understand. See, here it is x transpose. The order of x is nothing but the n cross 1. So obviously the x transpose would lead 1 cross n. Yes. Now it's getting multiplied with the matrix Q. What's the order of matrix Q? It's nothing but the n cross n. Similarly, it's a matrix X which has the order of n cross 1. Once you'll multiply them together, first focus whether their multiplication is possible or not. Definitely, sir, it's possible. How? Here the number of column and number of rows are matching together, and similarly number of columns and number of rows are matching together, and end of the day the resultant matrix would be in order of 1 cross 1, which is my basic requirement. Not only that, if you'll focus over the R transpose into X. Anyways, what is the order of R? R is nothing but in order of n cross 1. So R transpose is in order of 1 cross n. 1 cross n, and it would get multiplied with the x, and the x is in order of n cross 1. The resultant is going to be simply 1 cross 1. Yes. Agreed? Till this moment of point, each and everything must be clear to all of us. So probably I do not find any difficulty till this moment of point. What they have been asking, the stationary point of f of x. Anyways, how the stationary point of the f of x is being calculated? Obviously, the student who have gone through the basic concept of the maxima and minima, they know bit about the stationary point. What does it mean by the stationary point? The stationary point are the point where the slope of f of x becomes 0. Probably it might be forming an extrema, probably it might be forming the saddle point at that point. But anyways, I do not worry about it. Whenever I say stationary point, by default, the first derivative of the function with respect to the independent variable has to become 0. Has to become 0. That's the point. That's the point. Yes. What I would do, just for making this problem simpler, I would take the value of n as 1. What I am doing? Just to keep this problem simpler, I have taken n as 1. N as 1. So how the f of x would be dealt as? F of x can be taken as half times of x transpose q x minus of r transpose x. R transpose x. My dear friends, the transpose does not make any sense if you have a matrix with the number of rows and columns as 1, because it would be in the same place. It would be in the same place. So as I have selected the value of n as 1, the x transpose would become x, and even r transpose would become r. Yes. And even their multiplication can be commutative. Why? My dear friends, you can see now. If you have 3 matrix, it's a 2, 3 and 4. Their multiplication is possible. May you know what would be their multiplication? Either you can take the multiplication of this first and then you can multiply with this. Either you can take the multiplication of 2 and 4 first and then you can multiply with 3. The same process we can follow. Same process we can follow. So here I can write half times of q can be brought it out. X transpose is very same as x. Now the x can be multiplied with the x, which would result x square. Which would result x square. The same process goes with r of x. R of x. Yes, and it would make a function f of x. Obviously, it would make a function f of x. And as far as this problem is concerned, we are searching for the stationary point. How we search for the stationary point? We take its differentiation and we compare with 0. We compare with 0. So what's the result we are finding? The 2 of x, the 2 and 2 goes out. The result what we have, it's simply q of x. Q of x. And here goes minus of r and has to get compared with 0. Has to get compared with 0. Yes, 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 my dear friends. So the value of x which we are getting now is still the q and r are the matrix. No, is still the q and r are the matrix. Nobody should get confused on it. So r goes towards right hand side. It would be r. Here still it is q. Here still it is q. So what you will do? You will take q in inverse both of the side. Once you will multiply q inverse both of the side, q into q inverse would become 1. So the point of x where the stationary point have been lying for this function f of x is being found to be q inverse into of r. Yes, that's the best thing. That's the best thing, or that's the outcome which we are getting. That's the outcome which we are getting. So the best most answer what we are getting is simply going to be q inverse into r. Q inverse into r. Now I would request to each one of you, even taking the reference of higher value of n, you had to solve this problem and had to get the answer as q inverse of r. And if you still having the problem while solving the higher values of n, you can ask that sort of doubt in next class. You can ask those sort of doubt in next class. Agreed, no? So now it's a time to take the last problem of the day. Last problem of the day. And keep in mind, it has been a problem from chemical engineering and it's a type of MSQ problem. That means you can have more than one answer. And yes, this problem is not coming from the concept of the linear algebra. This problem have been coming from the basic concept of the calculus where we check the limit, continuity and the differentiability of the given function. Anyways, without getting delayed, let me copy this problem out and bring it to the working board. Yes, here goes the problem. Here goes the problem. Tell me what would be the best most answer for this given problem. See what the problem has been given for. For the function f of x is equals to of minus of x for x less than 0 and similarly x square for x greater than equals to of 0. The correct statement is r. it has been clearly mentioned is and are. Is means it can have only one answer, are it can have more than one answer, and it's type of MSQ. It's type of MSQ. Tell me what would be the best most answer. There could have been the two different methodologies. Either drawing the graph of f of x, you could have straight away solved this problem within probably 1 minute, or with the help of differentiability and continuity test, you could have solved this problem. Anyways, I would use the best most method, and that is nothing but the graphical method. And I would expect each one of us must be very well acquainted to draw at least the graphs related to the line, parabola, hyperbola. My dear friends, what I would be doing at very beginning, I would be taking the reference of xy plane. Here goes the y-axis, here goes the x-axis. Here goes the x-axis, here goes the y-axis. As far as the f of x is concerned, it has been bifurcated in the two parts. For the range x lesser than 0, for the range x greater than equals to 0. What does that mean by the minus of x? It has been a straight line having a slope is equals to -1 and having the constant c is equals to 0. That means it would pass through the origin itself. So obviously we can draw this out. So this curve would be sort of this. Yes, no? How we can define this? Because its slope is being -1, and yes, it is trying to pass through the origin. But it has been defined till x less than 0, not even at x is equals to 0. So at x is equals to 0, it would make a hole over here. Now we have got another function which is y is equals to x square. Which type of curve it used to be? It used to be upper facing parabola. But this parabola is defined only for the range x greater than equals to 0. What does that mean of it? That means it would make a dot over the origin. And from here onwards, it would make a parabola. And this is nothing but the curve of y is equals to x square, or simply f of x is equals to of x square. Now you yourself would be able to comment over the 4 number of options which are attached along with this problem. F of x is differentiable at x is equals to 1. Yes, my dear friends, at x is equals to of +1, the function is found to be smooth and continuous. Yes, that means the unique tangent can be drawn over x is equals to 1, which would be somewhere positive. If you want to know the worth of the tangent, simply you can differentiate it. It's going to be 2 times of x, and you'll feed x is equals to 1. So definitely you get the worth as 2. The slope is going to be 2 now. Obviously, A is the appropriate answer. Fx is differentiable at x is equals to 0. No, my dear friends, at x is equals to 0, there is a formation of a curve. That means you cannot draw a unique tangent over this point. It is not making a smooth curve on which the tangent can be drawn. It is just a point. Over the point, the infinite number of tangent can be drawn, which would not be the unique one. Obviously, the B has been ruled out. Now they have been discussing about the continuity. My dear friends, this complete curve, this complete function has been continuous for all possible real values of x. Either you include 0, either you include 1, or either you include any of the real value of x. So f of x is continuous at x is equals to 1. Obviously it is, sir, and even it is continuous at x is equals to 0. So what's going to be the best most answer for this given problem? Obviously the best most answer is going to be A as well as C as well as D. Agreed? A as well as C as well as D. And now if the student would try to calculate this answer with the manual method of mathematical calculation, where we used to have a calculation like f of c minus h when the h is tending towards 0, f of c, then f of c plus h, where I would be taking the 2 different test points. The first test point would be at x is equals to 1, the second test point would be at x is equals to 0. That is for the continuity test. And now if you had to perform the differentiability test over x is equals to 1 as well as x is equals to 0, such a hell amount of time you would be spending. So I would request to each one of you at least have a little bit idea about the important curves which includes straight line, which includes parabola. The parabola could be in the form of y is equals to plus x square minus x square, x is equals to plus y square minus y square. Have a little bit idea about the trigonometric functions like sine, cosine, tangent. Have a little bit idea about the circle, and at least have a little bit idea about the different kind of structure like ellipse. So this many things must be there within your mind. First, the linear equation, line. The second could be parabola. The third could be circle. Next could be ellipse, and the next could be trigonometric functions. The graphical understanding of this many functions must be by-hearted to all of us. Otherwise, you may get trapped at least in one problem within your GATE examination. Maybe that problem might be falling within the engineering mathematics, or that problem might be falling within your core technical part. So may I know what's going to be the best most answer? A, C and D has been ruled out. So the best most answer is going to be A, C, D. Anyways, from tomorrow onwards, we are going to smash the next category of the problem or the next topic of the problem, where I would be taking the questions which have come from the topic called continuity, differentiability, limit test, as well as the numerical problems related to the limits which have appeared in GATE year of 2021. So I would request to each one of you, the student who are attending this class in continuous fashion, they must be learning at least the pattern of the questions which have been asking again and again, and which will help you a lot if you are preparing for the GATE 2022. So I would request to each one of you, try to share this session to maximum people so that they would also get benefited. Anyways, this is what all for today's lecture. We'll meet with the next video tomorrow precisely at 9 p.m. Obviously, the span of the video is going to be 9 to 10, precisely 1 hour. Thank you. Thanks a lot. Good night.